Hey, what's up guys? Welcome to Module 9 of the CompTIA A course. Now I'm sure you already know by now that CompTIA's A course consists of 18 modules and it consists of Core 1 and Core 2. So in other words, it's divided into two. Core 1 goes all the way from Module 1 to Module 9. So in other words, today we're actually covering the last module of Core 1. And then Module 10 will be the first module of Core 2, which is going to go all the way to Module 18. Now, as for the topics in today's module, here they are on the right hand side, as you can see. So we've got NIC properties, network connections, IP address configuration, small office, home office networks, wireless settings, firewalls. That can actually be a lot of things, but for the most part today we're going to be focusing on the Windows firewall, remote access tools, and IP configuration issues. Now, like usual, this list is just the main topics we're going to be discussing. It's not the only topics. And if you would like to know what most of the topics are, you can actually go check the description down below. That should give you a better idea. Normally in the description down below, I've got timestamps for you guys for your convenience. So be sure to use those timestamps if you just want to refresh on certain topics. If you're looking for a certain topic, use the timestamps. That's why I put them there for you guys. So guys, as you can see, I've done a lot of effort of these videos. So please give the video a like. That does help my video. It does help my channel. And if you're new on my channel, maybe subscribe down below with the notification bell. At least then you'll know when the next video comes out. If you don't do it with the bell, you're not going to know. Unless you're lucky enough to see it pop up somewhere. You never know. YouTube works weird like that. So since we've got all the formalities out of the way, let's jump right to it and get to our first topic. Alright guys, here we are. Our first topic in our last module for Core 1 is NIC Properties. Now, as I'm sure you guys probably remember from our previous modules, NIC is an abbreviation for Network Interface Card. That is the actual card inside your laptop or desktop that allows your machine to connect to a network, either via cable, in other words Ethernet or LAN cable, or via wireless, like a hotspot of some kind. So you get two kinds. In a laptop, you probably have both. In a desktop, you probably only have the one, which allows you to go and plug a network cable in with the good old-fashioned RJ45 connector. So computer's network adapter connects to a network appliance, and what is meant by that is you're probably going to end up connecting to something like an AP. AP, which means access point. So it's a wireless access point that basically just broadcasts your company's network or your household network to make it wireless so that you can connect to that network wirelessly via something like your laptop, tablet, or phone. Now, card settings should be configured to match your network. This applies to both physical cables as well as wireless networks. It includes, but is not limited to, things like your IP address, your subnet mask, and if you intend on actually leaving your household network or your company's network and going out to the internet, you're probably going to need something like a default gateway, and you're going to need a DNS as well. So all of these are things you need to go and look at. It's not limited to just that, but that's the main things. It can obviously include things like your firewall settings, turning it off or on. It can possibly include, turning on network discovery if you want to be visible on your internal network. So you can see it can actually be a lot of things. That is NIC properties, guys. Another topic we're going to be looking at today is QoS. It's an abbreviation for quality of service. Now, the topics in this specific module are going to be all over the place. I'm not going to lie about it. And I apologize for that, but I've got no control over that because I'm following the topics in the order which CompTIA has basically presented them. So if it's all over the place, well, blame CompTIA for that. So quality of service is basically a toolbox of things. It's not just one thing. And this toolbox of tools and things basically allow you to go and control traffic on your network, the way your traffic behaves. Now, if you're just going to go and connect all of your people in your company to a network, let's say you've got 100 or 1,000 people, there would probably be no QoS in place by default, which means your users can do whatever the heck they want. So I want you to imagine that you've got a few people on the network that's downloading a movie, perhaps, probably from an illegitimate source they're not supposed to be doing. And that is obviously going to put a lot of strain on your WAN link. Those softwares tend to use all the available bandwidth, doesn't matter how fast it is, they try and use all the available bandwidth by default. Now at the same time, on that very same network, you might have a few folks they would like to go and use Microsoft Teams or Zoom or Skype. They're trying to make some sort of voice call. They might have a webcam on, they might not have it. But the point here is what's going to happen is that call is going to start breaking up. And they're going to be unable to hear one another, those people, which is very annoying. And that is because that download of those people is basically hogging all the available bandwidth. Now, one of the things we can go and do in quality of service is bandwidth management, which allows you to go and control how much of your bandwidth goes to each people. So I've got a picture here for you guys. Here we go at the picture. So on the right, that's basically the total amount of bandwidth we've got available. And I suppose we can make it a round number. Imagine you've got a 100 meg fiber line, which is supposed to be used by everybody in your company, in your organization. That 100 megabytes needs to go to phone calls, web browsing, email, downloads, you name it, all of it. Now, if you've got bandwidth management in place, which is obviously now a division of quality of service, you can go and dedicate some of that bandwidth to certain types of traffic, like voice, in other words, audio. So if you look at the red one there, that could potentially be audio. That could be your Skype, your Zoom, your Teams calls, those kinds of things. And I can go and say, you know what? Out of my 100 megs, I want to go and dedicate 10 megs of that. Come what will, 10 megs will be going to my audio. And 10 megs will go to my video. And the rest that's available, that's left over, is going to go to all the other kinds of traffic we basically have here. So now what's going to happen is if someone is web browsing, downloading stuff, or doing whatever on a network, they can never tap into that last 10 or 20 megs. So 20 megs has been dedicated to audio and video, of which 10 is going to go to audio, and 10 is going to go to video in this case. I'm just sucking it out of my thumb as I'm going along. So it could very well be that at that point in time, maybe nobody is making a phone call, nobody, and someone's doing a download, but they can only reach about 80 megs of the 100 megs. The last 20 megs is inaccessible. They cannot touch it, which always leaves that open for audio and video. That effectively, my friends, is quality of service. It basically just makes the quality for certain types of traffic so much better and so much smoother. Here we have ourselves another topic, and this one is called Wake on LAN. In some cases, some of us would just refer to this as VOL or WAL, depending on what country you're in. So in your BIOS or your UEFI, it might be just listed as WOL. Wake on LAN is what it stands for though. So what this does is it allows you in a nutshell to turn machines on remotely. So as long as these machines are plugged into the network, wirelessly speaking, it could also be plugged in, I suppose. So as long as they are on the network, if you turn those machines off, and if they're still on the same network as you, generally speaking, you have the ability to go and turn them on. So what your machine is going to go and do is it's going to send them a magic packet, which basically just says, hey, psst, wake up. That's what's going to happen in a nutshell. Now, in the old days, about 10, 15 years ago, we had to go and turn this function on first. You first had to go into the PC's BIOS back then. Nowadays, it's UEFI. You had to go into the BIOS. You had to go and look for something called WOL, in other words, Wake on LAN, and you had to go and enable it because it was disabled on most motherboards. Once you've enabled that, you need to sometimes go and install softwares and all kinds of stuff. Nowadays, it's not necessary. So the picture on the right is actually very outdated. It's not really even necessary to go and do that. Nowadays, there's a lot of softwares, just Microsoft alone. There's a lot of softwares you can go and use that will automatically do all of this for you. All you need to go and do is install it on the machines that need to be managed. And that's that. You can go and manage them remotely with your machine or your server. It is that easy. So all you guys need to know at this point in time is it allows you to start machines remotely so that you can go and do things on them remotely. This is normally things like updating them. I mean, if you've got 100 machines in your company or 1,000 machines, and they all need to be updated after work, after hours, are you really going to go to each and every one of them and turn them on so that you can go and update them? Heck no. So instead, why not just wake them all up in one go from one PC? And this can be done. So that's what Wake on LAN is used for. Now, as for network connections in Windows 7 and Windows 8, please note that this is specific to Windows 7 and Windows 8. We're going to get to Windows 10 in a moment. That is what it used to look like. So if you still happen to have Windows 7 or Windows 8, you probably know that is what it still looks like. That hasn't really changed. And I doubt they're going to change that anytime soon because they've got their hands full, Microsoft. And with them obviously releasing Windows 11 now in October in 2021, I think they've pretty much got their hands full at this point in time. So what you're going to see there, whether you're using Windows 7, 8, or 10, is your kinds of network cards you've got. In this case, I can see it's a cable. It's not Wi-Fi. It's going to show you how many cables you've got plugged in, how many Wi-Fi frequencies you're connected to. On the average machine, it's probably just going to be one cable. Most desktop PCs only have one port, one RJ45 port, and that's that. Laptops have the ability to be connected to a cable as well as a hotspot at the same time. So you can, however, go and add additional network cards into your desktop PC if the need arises. So you can have 2, 3, 4 cables connected to your PC. We don't really do that with a normal personal desktop PC. That is more something you'll see with a server environment, if that server needs to be on more than one network at the same time, or if it needs to have some form of load balancing or redundancy happening on it. That is why you'll probably go and do that. So now how do you get to this menu? You simply just go to Network and Sharing Center. So up until Windows 8.1, you could just go right click on the little Wi-Fi bars at the bottom right of your computer, or the little computer icon, depending on if you've got a cable plugged in or if you're on a hotspot. As soon as you right click on it, one of the options you're going to see there is Troubleshoot, and the other one's going to be Network and Sharing Center. Now in Windows 10, that used to be the case as well, and in one of those many updates that keeps coming through in Windows 10, they've changed it. Now it just says Network and Internet or something like that. We'll go and check it now out in a moment, but it's changed. It used to take you directly to Network and Sharing Center. Now it does not. Now it takes you to the new Settings app, which is effectively the new control panel, the replacement for the old control panel. And via the new Settings app, you're going to have to go navigate your way to Network and Sharing Center, which is fortunately for us still there. Now as for Windows 10, that's what it looks like. It looks slightly different, as you can see. Still very much the same, but not exactly the same. So it's probably going to go and take you to this little window at first of all. So if you're going to go to Windows 10 and you're going to go right click on the little computer icon or the little Wi-Fi bars, this is more or less where it's going to take you. So I think enough talk. Let me show you guys on a virtual machine that I've got in the cloud with Windows 10 on it. We've used it before on some of my other modules. So I'm going to show you guys on that virtual machine what this actually looks like. Alright, so here we are on my virtual machine, which is running in the cloud. It has Windows 10, as you guys can see. And normally on a Windows 10 machine, you'll either go click on the little computer icon here at the bottom right, or the little Wi-Fi bars, depending on what you're on. You right click on it, and up until about a year or two ago, this used to actually say Network and Sharing Center. Now it says Open Network and Internet Settings. So at some point, one of those updates changed this. So if you go and click on that, this is what it looks like real time right now. And then from here, you're going to have to go look for the Network and Sharing Center. So if I scroll down a little bit, there we go. Network and Sharing Center. And if you click on that, that is actually what it looks like right now at this point in time. And from here, you can go and see how many network cards you've got. It's going to either show you little Wi-Fi bars there. It's going to show you a little cable icon. In this case, that's a cable. It's virtual, obviously, but it's a cable nonetheless. And I have the ability to go and click on that. And I can go here to Properties. And here you can go and configure your IP version 4 addresses. And there you can go and configure your IP version 6 addresses. IP version 6 is not really something we cover in this course, so we'll probably end up going here to IP version 4. Go click there on Properties. And this, my friends, is where you're going to go and configure your IP address. At the moment, it's on Obtain an IP address automatically, which is a dynamic IP address. Which means this machine, as soon as you connect it to a network, or as soon as you turn it on, it's going to ask for an IP address because it doesn't have one. It's going to ask for one from the DHCP server. More on that in just a moment. That actually is covered to a certain extent in this module. If you were to go and click on that one there, that's a static IP address, also known as a fixed IP address, where you get to go and type in your own IP address in here, or someone else can go and type in one. That is a manual fixed IP address. It's going to stay like that until you or someone goes and changes it one day. So it's a fixed IP address, what we're saying. So more on that in a little bit. So let's go back to our little pictures. So here we go, pretty much what we just said. IP address configuration. Configure wired and wireless through connection properties. So it doesn't matter if it's wired or wireless, both of them is going to be the same way. Default is dynamic, like we just seen. So that little first radio button there, the one that says obtain an IP address automatically, that is the default. Now, I showed you guys this on a laptop or a desktop, but the fact of the matter is most devices actually are on automatic. That includes your phones, it includes your tablets, and quite frankly, most devices out there. So if you go and take your phone or your tablet and you try and connect to your home Wi-Fi or your office Wi-Fi hotspot, whatever you want to go and call it, it's actually an automatic. And as soon as you connect, you type in the password, assuming there is one, it's going to automatically do an ARP request. So your phone or tablet's automatically going to say, hey, is there a DHCP out there? And if there is one, DHCP is going to say, yes, I'm here. How can I help you? And your device, whatever it might be, is going to say, hey, dude, I need an IP address. And if that DHCP has one available, let's say if it might not have one available, maybe they've all been depleted, it's going to issue you with one. And as long as that IP is valid and as long as it has not expired that lease, you can go and use it. Now, dynamic IP addresses actually have a lease assigned to them, which means they expire after a certain period. I cannot tell you exactly what that lease is because it depends on what your administrators has configured it. So whoever set up your DHCP, they have the ability to go and choose the scope, in other words, which IP addresses get dished out, how many there are, and how long that lease lasts. Now, if they just go in with all the defaults, it's actually probably going to be about 8 days. That's the default. But most organizations will go and reduce it from 8 days all the way down to 24 hours. So in the average organization, the average dynamic IP address generally lasts for 24 hours. So what's going to happen is you probably would have gotten one if you connected to that network or you turn on your machine. And after 24 hours, if that machine has not been turned off yet, that IP address would expire. And if it expires, you're going to see you still have an IP, but you cannot go and do things like access the internet. And that's normally when you're going to find people contacting you saying, my PC does not work. And they have no clue why, because everybody else's PCs work. And it's generally because all the co-workers turned off their machines after work, and that person probably left their machine on throughout the night. Now, why does it make a difference when you turn off your machine? If you turn your machine off or you disconnect from the network, it releases that IP address back into the pool. So that's pretty much why it does that. And when you turn your PC back on or you plug it back into the network, it requests a new IP address is what happens. So yeah, let's move on to our next topic being SOHO networks. So SOHO is just an abbreviation for small office, home office. So you can imagine this as a very small office which contains about 5, maybe up to 20 people or so. Generally consists pretty much just of a router. You'll be lucky if you've got an access point. It's normally just a router with an internet connection, obviously. There might be 1 or 2 printers. Most of these folks working there will probably have like a laptop or a desktop and some phones. And that's pretty much it. It's unlikely it'll have a physical firewall or any fancy things like that. For the most part, very simple, small setup. It might actually be a household, an actual house that's been converted into an office. You get that a lot in some countries where people will go, instead of renting an actual office in the business district of town, they will go and take a house, that's in a relatively busy area, and convert that house into a small office, home office environment. So business networks may use centralized server as well as clients, often use a single internet device for connectivity. That pretty much is the case for all of these small office, home office environments. It's normally one internet connection, one router, and if that router goes down, in other words, that one internet connection, yeah, you're going to be in a pickle. Maybe home or residential network as well. So it could be a matter of maybe that household is actually your house. So maybe that small office home office is not just a small office home office, it really is your house. It could be that maybe you are working from your home and you've got 2 or 3 or 5 other people coming to your house every day, and they come and work in a dedicated section at your house, which is a small office home office environment. So there's a lot of possible situations we can actually go and play out here. Now, with regards to small office home office environments, you get networks. Now, that network is 10 to 1 only going to be a router or a router, some of you guys might call it. It might be an access point that's also included in that network, but I find that very unlikely. Now, whether there's an access point or a router or just one, either way, you're going to access these devices over the network the same way. You're going to connect to them, and you're going to configure them more or less the same way. So there on the right is an example of a random router kind of setup. It's not necessarily what yours is going to look like. Every router out there looks different, even if it's the same make. I can have one make and you can have the same make as me, but just because you've got a different model, the whole menu is going to look different. So whatever you guys see in the pictures with regards to routers or routers, please take them with a spoon of salt, never mind a pinch of salt, because that's not what yours is going to look like. That is just to give you an example of more or less the options you'll have available. So in my example, you can see there's a bunch of tabs and you can see some of the options available there. So you will essentially have the same options available, but it's going to be in different places. It's kind of like maybe I've got a phone which is a Samsung and you've got a phone which is a Huawei. They can do the same thing essentially, but the menus might look different and where you find some of these goodies and features might be different. But they do the same thing in a nutshell. So yeah, what you need to know is if you want to go and connect to these devices, we've said it's the same, but how is it? How do you actually do that? You plug it into the network. It's normally with a network cable. So that router or access point is going to be plugged into your network with a network cable. You're going to connect to its IP address, which in most cases will probably be 192.168.0.1 or .1.1 at the end. Most devices, routers, access points, firewalls, switches, you name it, majority of devices tend to use that as a default IP address. So as soon as you connect to that device via your browser, you're going to open your browser, you're going to type the device's IP address in, it's going to load a page which looks like a web page. In reality, it's pretty much just that device's portal or console. It's not really a web page, it just looks like one. So on that page, it's going to generally ask you for a username and a password. The username could quite frankly be anything, but in most routers and stuff, it's usually admin. Most brands like using the username admin. The password could either be blank, it could be something like admin1234, or just admin, so you get an idea. It can actually be anything. So I would say refer to your manual, but you can actually find it online as well. So if you know what make it is and what model is, a quick Google search, and 5 minutes later, you'll know exactly what that password is, at least what the default one is. Now, since it's so easy to find these passwords, especially as technicians, it's highly advised that you go and change that password. That's one of the very, very first things you're going to go and do, not just on routers. The topic at hand is a router or router, but this doesn't just apply to routers. You're going to want to go and do that on any device that you just bring into your network. So one of the first things you're going to go and do is change the password and also change that IP address. So go and look at what IP address range your network is using. Make sure you use the right range and change that last digit so it's not .1, so that it's at least something else. Otherwise, if you bring in a new network device into your network, since they all use the same default IP, you're going to have yourself a conflict. We don't want a conflict because then they're going to kick each other out basically on the network. Very inconvenient. All right, so let's take a bit of a peek at wireless settings. So on your router, you will have the ability to go and configure some wireless settings. What exactly you can configure regarding wireless depends on what make it is, what model it is, what functions it has. At the end of the day, like most things in life, the more you pay, the more you get, the more goodies and the more functionality you're going to get. So some of the things you can go and configure is the frequency itself. In other words, do you want to broadcast signal at 2.4 or in 5 gigahertz or both? Some of the latest models nowadays can actually broadcast on both of them at the same time. So you can literally go and scan of a laptop, a phone, or a tablet, and you'll find there's two hotspots that's actually coming from the same device, two Wi-Fi frequencies. It's going to look like it's two different networks, when in reality it's the same network, it's just being broadcasted at the same time in two different frequencies. So yeah, you can go and configure what we call the SSID. That is just the name. So if you look at that picture on the right, they've called it CompTIA underscore wireless LAN, but that is probably going to be the name of your business or the name, your last name or something. So if you are going to go and connect to that Wi-Fi, what name do you want to have displayed? So if my company is called Burning Ice Tech and you are going to come into my organization, my hotspot or my Wi-Fi's SSID is probably going to be Burning Ice Tech. If you're in my lobby, it's probably going to be Burning Ice Tech underscore guest. Maybe it's a guest Wi-Fi, which has got limited speed and it's got restrictions on it. And if you're a staff member of mine, it might just say Burning Ice Tech staff or just Burning Ice Tech. I'm just using my name as an example here for my channel. So you get to choose the name. Now it's very easy to go and fake someone else's Wi-Fi, so I can just go and grab an access point. I can go and grab a router, or you can even do this with a phone or a tablet or a laptop these days, because they can make hotspots on phones, tablets, and laptops these days. So you go make a hotspot and you simply just give it the exact same name. the same SSID. So that can actually trick people into connecting to the wrong network. And that's actually also a security risk in some cases. Then we also have security and encryption. Now, regards to security encryption, you get WEP, which is the very first one that came out, very unsecure. I would say it's better than nothing, but it's still very, very unsecure. Then you have WPA and WPA2. So the oldest one is WEP, the middle one, WPA, and the latest one, which is the best one, is WPA2. Those are securities in encryption. So it is very important to go and add security to your wireless frequency. Never mind a password. You guys can see in the picture, you can obviously go and choose a password. But the actual encryption needs to preferably be WPA2. The only time you're going to go and choose WPA is that some sort of device on the network does not support WPA2. And nowadays, pretty much all devices I've come across support WPA2. So your rule of thumb is to by default choose WPA2. That, my friends, is not just a question exam, it is a lab or a simulation exam. They're going to give you some sort of router. It's not necessarily going to look like mine. You're going to go onto that router. They're going to keep it very simple. It's a lot simpler and a lot easier than the average router. Very, very straightforward. And one of the things you're going to have to go and do on that simulation is you need to go and configure security, specifically encryption. And I think the question was something along the lines of you need to choose the most secure one. Now, if you need to go and choose the least secure one, what are you going to go and choose? It's going to be WEP. If you need to go and choose the most secure one, it's going to be WPA2. Now, if I give you a list of encryptions, let's say I give you all three of those, and I ask you which one is the least secure, obviously it's WEP. If I ask you which one is the most secure, obviously it's WPA2. Now imagine for a moment I remove WPA2 from your available list of answers. And if I ask you then which one is the most secure and I only list WEP and WPA, which one are you going to choose? It's just obviously the next one on the list, which is not WPA. That might be a situation you guys can encounter in the exam. They might give you a question and they're going to ask you which one is the most secure or the least secure. And instead of listing all three of them, they might very well just list two of them. And out of those two, you might have to go and choose which one's the least secure and which one's the most secure. All right, and then you also have a password, as you guys can see there, and you can go and choose your 802.11 mode. So do you want just G? G is the normal router or access point frequency. Or do you want N and G? N is the long range one. Or, so you can go and choose all kinds of things there. Now, how do you want to mix and match this? Obviously, the more you choose, the better. The more ways you can go and connect to it. You can go and choose your channel width if needed. Most people leave that on auto. I mean, I myself leave the channel and the channel width on auto. It's very rare that I find myself actually going and changing that. Now, as for DHCP and IP address configuration, this is actually something you can go and do in your router. Now, if you are in a proper company, which is a medium to large size organization, you're definitely going to have a DHCP. And I can almost guarantee you that DHCP is going to be on an actual server. It's going to be an actual server, which has got the server operating system installed. And they probably went and added a role called the DHCP role. Now, in a household environment or a very small office, home office environment, you still have a DHCP, but it's not an actual server. It's normally your router that acts as if it is a DHCP. Your router generally has a DHCP function built into it. We don't always use it though. So if it's a small household, average household or an average small office, home office environment, you might not have a server. You might only have your router. And that little doohickey, that little device called your router, it will go and dish out IP addresses for you. So if that is the case, you might have to go into the router and go and configure it. In most cases, we don't need to. Your ISP would probably have pre-configured it for you. But if you prefer to go and do things yourself manually, you do have the option to go and log into that router and go and choose from what range to what range. If you look at the picture there, you'll see there it says IP address pool. So if you were to connect to this network, there is obviously a DHCP server. You can see it says enabled DHCP. So DHCP is on, which means if someone connects to this network, they will automatically get an IP, assuming the device has been configured for dynamic, like we discussed earlier. And you can see the radio button which says DHCP server is configured. And the IP these people will get when they connect to your network is going to be something between 1 and 199. So it's going to be 192.168.1, and then that last digit for them is going to be something between 100 and 199. So there's about 199 to 200. No, I'm lying. There's about 99 to 100 IP addresses available here. So you can only have about roughly 100 people on this network. As soon as you start going over that, the people are just going to hover there and nothing's going to happen. On their device, it's either nothing's going to happen, nothing's going to work and nothing's going to happen. Or on a desktop or a laptop, you might sometimes be lucky enough to have it say obtaining IP address. Obtaining IP address. It's just going to keep saying that until one of the other 100 devices disconnects or turns off, which means they release that IP address back into the pool. Now, DHCP relay, the one that's the other radio button there, relay, not something we need to know at this point in time. It's not really part of today's module, but that is when this modem or this router of yours is not the server. Instead, it is getting IP addresses from somewhere else. You're relaying it. It's dishing it out on behalf of another DHCP server. So somewhere else, you've got a DHCP server, and your router is dishing out those IP addresses on behalf of that actual DHCP. So in this case, they've clicked or checked the little radio button that says DHCP server, which means your router is the DHCP. It chooses what IP addresses you get, and this is where you're going to go and configure it. Whereas where you go, if you were to go and choose DHCP relay, you don't really get to choose what your range is. You just go and choose where the server is and what the server is for that matter. All right, so let's talk about access point placement. Now, access points is what we refer to as an AP normally. That is a terminology you guys are going to hear quite often in A+, and actually just in general in IT. You're going to hear about people talking about APs. That is your access point. It is the device that you plug into a network cable, which simply just makes your network wireless. So your router obviously does that as well. You can go and plug in up to 4 network cables into your router, for devices, and your router broadcasts your signal, your network wirelessly. But what if you've got a very big household or a very big office? There's going to be spots which is too far away from your router. So what you could do in that situation is you can go and plug in network cables into your router, and how you go and get them to the other side of the building is up to you. You can do it in the walls, under the floor, in the roof. It's probably going to be in the roof. And once you get to the other side of the building, wherever this signal is needed, you're just going to go and take that network cable, plug it into what we call an AP, access point. It's going to take that signal and just rebroadcast it. So now you're just extending your wireless reach is what you're doing. So now people can be further away from the router now, and if they're away from your router, they'll instead just connect to the access point. And if they are nearer to the router versus the access point, we're going to connect to the router. Whichever one is closest is the one they're going to be connecting to automatically. So you're just taking your network and making it wireless. That's all it does. So all you need to do in most of these cases, you just plug an network cable into the device. In a company environment, that's probably going to be a PoE cable, which means it sends power through that network cable. So the only thing you plug in is a network cable, and it's automatically going to power back on. If it's a situation where it's a small office, home office environment, you probably do not have a PoE switch or a PoE device. So in that case, you plug in a network cable and a power cable to power that device of yours. Now, it's very crucial that you go and check where you've got no signal or very weak signal so you can go and place the access point in the correct manner. You also need to go and check, if there's thick walls or something that can disrupt the signal, that's going to be a problem. So thick walls is going to disturb your signal. And if you've got, metal on the walls, metal file cabinets, anything that's large, huge, and probably made out of metal can influence your signal. It's going to make it weak, or it's going to basically render it useless. There's also certain devices you need to be aware of that's going to influence your wireless signals. This includes, but is not limited to, cordless phones. That's an actual device listed in the A+ course. It can also be microwave ovens, which is also something listed in the actual A course. Cordless phones and microwave ovens run at 2.4 gigahertz. And as you guys might remember, the 802.11g and some of the other frequencies run at 2.4 gigahertz. So if you're going to have your access point near a microwave, or if you're going to have it near a cordless phone, there's a very good likelihood that that phone or that microwave oven is going to influence your signal, and people are going to have disturbances. So in a situation like that, you should either move the access point away from those devices, or consider moving to a different frequency, like 5 gigahertz, as you guys might remember. So 802.11.a is pretty much the same as 802.11g, except A runs at 5 gigahertz, where G runs at 2.4 gigahertz. Okay, and then let's take a look at radio power levels. Now this is basically just the signal strength of your access point or your router. In other words, how far away could you stand from that device or be away from that device and still be able to receive a signal? Now, some devices, not all, I would actually say most devices do not have this functionality, but some of them actually have the ability for you to go and choose how strong you want that signal to be, the power level. Now, the more you boost it, the further away you can be from that device and still connect to it. The more you reduce it, and yes, we actually do reduce it in quite a lot of cases, the more you reduce it, the nearer, the closer you have to be to that device to be able to connect to it. Now, in most cases, we do not actually boost it, we actually reduce it, believe it or not. Hard to believe, right? Why would I want to go and do that, though? That is something we do to prevent people from connecting to our access point, or hotspot, or our Wi-Fi network, people that's not supposed to be connecting to it. So if you've got people physically within your office or in your house for that matter, and those are the only people you want to connect to that access point, what you could go and do is you could maybe ever so slightly go and reduce the radio power level of that access point so that it broadcasts far enough for the people within your building to be able to connect. But as soon as you are outside the walls, basically, you should not be able to pick up that signal, or it should be so weak that it's basically rendered useless. So it needs to, in other words, stop pretty much exactly where your walls stop, is what we're saying. So if you've got an office building, let's imagine it's a small office, home office environment, and this access point is more or less in the center of that room. You want the signal to be strong enough for people within that room or that building to be able to detect it and connect to it with no problem. But as soon as you are outside your walls, someone should either not be able to pick up that signal, even if they know it's there, they should not be able to pick it up, or if they can, it needs to basically be so unstable and so weak that they can basically not do anything with it. So all of this is done for security reasons. It prevents people from doing something we call ward driving. As you can see there, it's a point on the left. Ward driving is a fancy term we use for people that's just driving around, walking around, scanning for Wi-Fi hotspots or access points. So you get people that actually does that. So there's a terminology called ward driving, and there's another one called ward chocking. Ward driving is going around, I could be walking, in a mall or a shopping center. Obviously, there's bound to be many, many hotspots there. You're walking around there and you're looking for hotspots that you can go and basically break into, or at the very least, try your luck with guessing the password or cracking the password. That's ward driving. Ward chocking is obviously just trying to break in there. So ward driving, to avoid people from detecting your network, and then obviously if they can't detect it, they won't try and break into it. So to prevent people from detecting it in the first place, you want to go and reduce the signal so that you basically have to be within the building to be able to connect to it. So in a nutshell, guys, that is what radio power levels is. It also prevents people from doing what we call an evil twin, which is basically just someone that makes an identical copy of your router or your access point. So they go make a router or an access point, they make another hotspot, they use the same SSID, they go mimic your password, or they go put no password on it, and it basically tricks you or your device into connecting to the wrong network. And that's used for all kinds of evil games. Just bad. It's plain bad. Now, here we have Wi-Fi security protocols, something we actually did discuss earlier when I showed you guys a little example of my fake little router, so to speak, or my fake little access point. So this is just a recap, so WEP, as we've said earlier, that is the oldest kind of encryption you get. It's legacy, as you guys might remember from one of our previous modules. The word legacy simply means old. Old software, old hardware, which is now basically being phased out. It's still better than nothing. You don't want no security. But if you've got a choice, you do not want to go and choose WEP, with that being the oldest one out of the lot. You're going to want to go and choose either WPA or WPA2. WPA2 being the better one out of the two, the newer one, So if you have no choice, I would say go and choose WPA. But if you have a choice, WPA2 is going to be your go-to one. In most cases, you are going to be choosing WPA2, and pretty much everything these days is compatible with that and supports that. But if you find yourself in a weird situation, a very unlikely situation, where that device in question only supports WPA, that's obviously going to be your next go-to one versus having to go to WEP. Alright, so let's take a look at some common small office, home office security issues. The first of which is your SSID. If you've been watching this whole module, you would know the SSID is the name of your hotspot, the name of your Wi-Fi. So if I am going to go and scan for the wireless network in my house or my office building, the names that's going to appear, the ones that you're going to go and tap on or click on so that you can go and connect to it, those names you see is the SSID. So simple name to identify the WAN, your wireless area network. Change default SSID. So by default, it's probably going to have some sort of manufacturer or factory, SSID in there. You're going to want to go and change that to something user friendly that suits your home, your needs, or your business. I would advise against using personal information. You can see there it says do not use personal information. So do not use your name. Do not use your last name. That is actually something that a lot of people use. And surprisingly, a lot of ISP companies, those are the guys that come and provide you with internet access and then sometimes even comes into your house or your company to go and install your hardware. When they come to personal households, surprisingly, they do change the SSID quite often. And surprisingly, they end up using your last name or your name in most cases. Do not allow them to do that. So give them some sort of fake name. You can even go and have a little fun of it. You can go and call it FBI surveillance van, and then maybe give it a number. So that'll scare the crap out of some people. So you can have some fun of this. You can actually, especially if it's your own household. If it's in your company, you might want to go and use something proper and professional that suits your company. You can also go and disable SSID broadcast, which means you do have wireless capability, but unless you know about the network, you're not going to find it if you search for it. So that's why we go and disable that. That's a form of security. It's not the only kind of security. So if someone knows about the network, they can still connect to it. So it's not going to stop people from connecting to it. It's just going to stop people from discovering your network. Obviously, you should go and enable encryption, like we just said, WEP, WPA, WPA2, preferably WPA2. With regards to physical security, restrict physical access to enterprise routers or routers and switches. We do not want people being able to go physically anywhere near those devices. They need to be locked up or inaccessible. So if someone is able to come into your office for whatever reason, these routers and switches need to be inaccessible, out of their reach. So if they are going to be in the same room, these needs to be in a little network cabinet locked up. Because if people have direct access to those routers and switches, there's a lot of things they can go and do. On routers and switches, you'll sometimes see the username and password written on them. So they can actually go and push a paperclip into them and reset them back to factory fault, factory settings, which allows them to go and connect because most of us IT people know the default usernames and the default IP addresses and the default passwords for most devices. And if you don't know it, you can find it in less than 60 seconds on Google, quite frankly. So we want to avoid this because they can go and reset those things. They can go and plug something into those things, causing even more mayhem. It's just plain bad. Avoid direct access with strangers. Attacker of physical access could reset to default and gain access, as they say. Updating firmware. So keep internet appliance firmware and drivers up to date. So this is probably going to be your router in most cases, but it could also potentially be your switch or even something as like your firewall in some cases. The better your firmware, the better. Or the newer your firmware, the better. It just, obviously increases the security, or decrease the security risks. I misspoke there. So the better your firmware, the newer your firmware, the better. Because that means any potential zero-day exploit would have been patched. So if there's some sort of vulnerability in your software that you were not aware of, at least it would have been patched now if you've got the latest version of your firmware. With regarding your static IP address, now for those of you that don't remember what a static IP address is, remember that is an IP address you go and configure, which is going to stay the same. It's also known as a fixed IP address. You need to go and configure that manually, or someone needs to. And if it's been configured, it will stay on that IP address until you or someone else goes and manually changes that IP address on that specific device one day. So static IP address assignments will not deter a determined attack. So yeah, I mean, if you're gonna go and configure static IP addresses, you're not gonna stop people. At the end of the day, you might just annoy them a little bit, but at the end of the day, it's not gonna stop them. Router and modem must have static IP to function as a DHCP server or a default gateway. Now, DHCP server is the server, which is not necessarily a physical server, that's going to be dishing out your IP addresses. So your router must have a fixed IP. It's normally going to be 0.1 or 1.1 on your network. The default gateway is the device that your PCs, phones, and tablets and stuff needs to go through to be able to leave your environment, digitally speaking, and to be able to go to the outside world, digitally speaking. And that outside world is for the most part going to be the internet. So if I have a laptop or a desktop within my house or within my office building, and I would like to access the internet, I'm not just going to need an IP address and a default or a subnet mask now anymore. I'm also going to need a default gateway. I need to tell my PC which device it needs to go through to be able to go to the outside world. You can imagine it's a very, very long river, and for the most part, you cannot cross that long river. But if you know where there's a bridge, you can actually go to that bridge and cross that river and get to the other side. Your router is basically like a bridge across a very long river. So if you know where that bridge is or where that router is, the route, the default gateway, you can use it and get to the other side, being the internet in this case. Next up, we have firewalls. Now, in case anyone is brand spanking new to this, no, it's not an actual wall, and no, there's not actual fire anywhere involved with this. This is just the name we've given to something that helps protect your machine, your servers, and your networks. The one we're going to be discussing today is the Windows firewall. It's a software-based firewall, and it's not the only kind of software-based firewall. You do, however, also get physical firewalls. It's an actual physical device that looks the shape and dimensions of a very large size switch, and these are quite often in your server room in an actual company environment. It's in your actual physical server room. Now, these firewalls don't just do what the average software-based firewall does, at least the hardware ones. Those hardware ones, they do a lot more. They have their whole operating system on there with all kinds of goodies and benefits. So that is something we'll look into more later on in a different video. But for today, we're going to be discussing just firewalls in general, and this is going to be more specifically your Windows firewall. Now, what does it actually do? It prevents people or software or malicious things in general from connecting to your machine and from gaining access to the outside world if they are on your machine. It blocks or allows ports, it blocks or allows services, it blocks or allows URLs, and all kinds of things like that. Now, what does it actually look like? Here you guys have a picture. So if you go into your control panel, which is luckily for the time being still there, don't know for how much longer it's going to be there, but if you go into your control panel, whether it be on Windows 10 or any other operating system, it's going to be in the control panel. You're going to go to your system and security, and then you're going to go to your Windows Defender firewall. It used to be called Windows Firewall, and this includes Windows 10. And then sometime not so long ago, one of those many large updates that we keep getting for Windows 10 changed the name from Windows Firewall to Windows Defender Firewall. So yeah. Now, if you go there, one of the menu options you'll have, and that's what we see in the picture, is you'll have the ability to go and turn it off or turn it on. Now, it's not the only option, obviously. We'll take a look at some of the other ones in just a moment. Now, if you have absolutely nothing else on your machine, this is still better than nothing. It really is not the best firewall. It kind of sucks if I'm being honest, but it's still better than having nothing. You're going to want to have this on. If you go and get yourself a third-party firewall or something that happens to include a firewall, they will generally take over from the Windows firewall and automatically turn off the Windows firewall. Pretty convenient, especially if these people are not tech savvy like you. And if you one day need to go and uninstall that software, which happens to be a form of firewall, they will generally also automatically turn back on your Windows firewall. So let's take a look at where we can find this Windows firewall. All right, here we are on that Windows 10 virtual machine we've been using in all these modules. So I'm going to go to Cortana or search, type in control panel. There we go. And as we've said in the module, we're looking for system and security. That's where you'll probably find your Windows Defender firewall. And there we go. Windows Defender firewall. And then here, there is the button that's going to basically bring up that picture we just saw a moment ago. The one that says turn Windows Defender firewall on or off. And if I click there, that is the page we saw in that picture a moment ago. Here, you have the ability to go and turn off your Windows Defender firewall. I do not recommend doing that unless you've got a very good reason. So if you're going to temporarily turn it off for 5 or 10 minutes just to go and do something, something that needs to be bypassed, so to speak, then maybe. So if you don't know what you're doing, leave this on. And if we go back here, something else you guys will see here is this function here. It says allow an app or a feature through the Windows firewall. And if I go in there, here you have the ability to go and choose an app by its name. So something common will probably be your remote desktop. So if I scroll far enough down for R, there we go, remote desktop. So this is actually obviously allowed now by default because this is a Windows 10 machine running in a cloud, and the way I'm connecting to it is remote desktop. It's usually turned off by default, but if this virtual machine is in the cloud, like on Azure in this case, this is running on Azure, then it will be turned on by default. Otherwise, how would I connect to this? So another form of firewall that you guys are going to be playing with quite often is the one here at the bottom left. It says advanced settings. So I'm going to go click on that, and there we go. So it looks complicated. It might look like rocket science even, but quite frankly, it is actually very simple. Do not judge a book by its cover, as the saying goes. So I'm going to go and expand this puppy here. Now, we've got what we call inbound rules and outbound rules. Inbound is things coming into your computer, your server, or your company's environment. Things that you, for the most part, are not aware of. Outbound is things leaving your environment, most of which you're probably aware of. So what you can go and do here is, and this actually applies to real physical firewalls as well, you get to go and set up what we call rules. And you'll probably notice there's a lot of rules here. I did not make these. These are here by default. So all of these rules are here by default. A green tick means that function, that component, or that service, whatever it may be, is allowed. You can actually see here under the action it says allowed. Now you, as the person that's going to be working on this machine, or the technician that's going to be working on this machine, you have the ability to go and add new rules under inbound and outbound. The way you do it for both is exactly the same. You go to the right hand side at the top, you click on new rule, and you go through the little wizard, and you can go and allow something or block something. Now the chances are you're probably going to end up blocking something because most things actually are allowed by default, at least everything that should be allowed. So let's show you guys what that actually looks like. I'm going to go here to new rule. You can go and choose whether you want to block or allow something like a program, a port. You can go and block or allow it by its name, by its port, or you can go and choose, from this list of predefined templates. I personally do not like this option here, because it only includes Windows things that's installed on Windows, nothing third-party wise, and even Windows wise, it doesn't include everything. So if you happen to find it in this list, be my guest. Go and use it by all means. But the chances are you're not going to find what you're looking for in that list. So you're probably going to end up using program, port, or custom. My personal favorite being port. So if I were to go click on port and I were to go click here on next, it allows you to go and choose whether it's a TCP port or UDP. If you don't know the difference between TCP or UDP, I would say go and choose TCP because the chances are it's most likely a TCP port. Most ports are TCP, which means the traffic, digitally speaking, is two ways. It's going to send packets of data both ways. UDP is one-way traffic, digitally speaking. So that will probably be something like a VoIP call, Skype, Zoom, Microsoft Teams. That's a one-way traffic example. Pretty much everything else, for the most part, is going to be TCP, two-way traffic. So here you have the option to go and choose a port or multiple ports. You can separate them with a comma if there's multiple ports. So if I were to go and say port 80, that's HTTP, Hypertext Transfer Protocol, or better known as normal web browsing, I can go and choose that. Next, what do you want to do? Do you want to allow it or block it? I'm going to say block it because obviously it's allowed by default. Next, for which networks does this apply? I'm just going to say all of them. Next, And then you give this a user-friendly name that's going to help you and your fellow colleagues identify the purpose of this rule. So imagine you come back to this machine, maybe it's not your machine, you come back to this machine 6 months, 12 months later, and you need to go and troubleshoot it. You're going to see this rule and you're going to wonder to yourself, what the cheese is this rule there for? What does it do? And why was it made? Meanwhile, you're the one that actually made it. And what if there's a situation of another technician that's going to need to come to this machine and troubleshoot it? So basically put yourself in other technician's shoes. What would you like to see? So obviously if you give it a proper name, we're going to know what it is, and you need to give it a proper description. So I'm going to say block web browsing. Well, now we know block web browsing. We know exactly what this rule does. Now, if another technician comes here and they see that rule, they're going to know what it does, but they're going to probably wonder to themselves, why would web browsing be blocked on this machine? You can go and write some nonsense like block web browsing so this person works during working hours. I don't know, that could be a reason. So maybe it's a matter of this person does not need a web browser to be able to do their work, and they're fooling around. They're going onto Facebook and YouTube and doing all kinds of stuff on Google when they're supposed to be doing their work. So you can actually go and block traffic, on port 80 on this machine specifically, and that's gonna, whenever they open a browser, it's simply just not gonna load. So I can go click on finish. I'm not gonna do that, otherwise it's really gonna block web browsing on this machine, and I don't want to do that. But all what's gonna happen is it's gonna give it that name. So that block web browsing is the name you're gonna see here. Instead of a little green tick, you're going to see a little red circle with a little red stripe through it, kind of like a little Ghostbuster circle. So that, my friends, is the Windows Firewall. Alright, and then as an extra, let's give you guys a bit of a peek of some of the settings you might possibly encounter with firewalls. Now, the ones we've seen listed here is not necessarily something you would find on the Windows Firewall. This is just in general what you may or may not encounter with real-life firewalls other than the Windows one. So generally speaking, you have the ability to go and disable ports or allow them. That is something you do have the ability to go and do in the Windows Firewall, as you guys literally just saw. So if a certain service should not be allowed in your company or on that machine, you have the ability to go and block it on that PC, that server, or that firewall. MAC filtering is also something you can go and do, not necessarily on the Windows firewall, but in general, it is something that can be done. It can be done on a router, access point, you name it. This can be done pretty much anywhere. Now, MAC filtering is not necessarily something you're going to find on the Windows firewall, but it can be done on a lot of places. It can be done on most firewalls, not the Windows. It can be done on routers or routers. It can be done on switches. It can be done on access points. You name it. Now, MAC is your computer's physical address, your social security number or ID number basically for your computer. It's unique to your machine and does not change. Now, a MAC filter blocks certain people and allows certain people. You can think of it as a bouncer at the door to a club or something. So when you try and go into the club or this restaurant, if your name is not on the list, you might not be able to gain access to that building or that facility. So what you can go and do is, we most commonly go and end up putting this on something like an access point. In other words, a hotspot. So if someone happens to have the username and the password for that hotspot, that little Wi-Fi frequency, they can try and type it in, but even though they might know the credentials, it's not going to give them access to that network, because that device they're connecting from, its MAC address has not been entered into the filter of allowed MAC addresses. So the filter allows you to go and make a list of blocked or allowed MAC addresses. Normally we block everything and just allow certain addresses. So I'm going to go and look at the MAC addresses or get the MAC addresses for all the devices that's allowed. So if I've got 10 staff members and each of these staff members have got 2 devices, maybe it's a laptop and a tablet, maybe even a phone, I'm going to go and get those MAC addresses for those devices. I'm going to add them into that little filter, and whenever they try and connect, no problem. But if anyone else with anything else tries to connect to that hotspot, guess what? It's not going to work. Now you also have something called content filtering, or in some cases parental controls, where you have the ability to go and choose what websites are allowed or blocked, what keywords are allowed or blocked, and just general things. You can even go and restrict times. Restricting times on, is more something you'll find on Windows 10, and that's more for kids. That falls more under parental controls. So Windows 10 actually does have the ability to go and enforce times. So if you've got kids in your house, you can go and specify times, of day when they're allowed to use the machine. So maybe you only want to allow them to go and use their machine between 4 o'clock in the afternoon and 6 o'clock in the afternoon. So they can do it every day, but as long as it's between 4 o'clock and 6 o'clock. So if one day they did not go and turn the machine on or use it during that period, they lose that day. They cannot go and suddenly log on later during that day. Has to be within that time slot. Or you can alternatively go and allocate them an hour or 2 hours per day, but it does not matter when they use it during that day. This is very much the same as an internet cafe of some kind, where you would go and buy an hour or buy 2 hours, of internet access. And when you use it is up to you, but you've got an hour or 2 hours access to the internet. You can also go and enforce that. And then lastly here, what we have is a whitelist or a blacklist. There are some similarities, between a whitelist and a blacklist and MAC filtering, because it's still a filter of some kind. So you can go and allow all websites and only block certain websites, or you can block all websites and only allow certain websites. That is the URL they're talking about. So URL stands for Uniform Resource Locator, not something you'll get asked in the exam. And in a nutshell, it is just the address for a certain website. So you can go and block certain websites or allow certain websites if the need arises. Now, something else we need to take a look at is port forwarding. Now, this is something that a lot of people don't know, and quite frankly, I think most people have no freaking clue what this actually is. Now, imagine in your small office, home office environment, or in your household, there's multiple PCs. There probably is multiple PCs. Now, if someone from the outside or something from the outside needs to connect to a specific PC within your small little office, so to speak, how do they connect to it? Now, what people and stuff from the outside will see is your public IP address, something we did discuss already in this course. So your public IP address is what's visible to the outside world. As soon as you go through a little router to the inside of your network, you're going to be using your private IP address. And if you go through the router to the outside world, in other words to the internet, you use your public IP address. So what I can go and do is, if you're rendering some sort of service for these people or whatever it might be, they will go and use your public IP address. They're going to be able to get all the way to your router in your office or your house. But once they get to the router or the router in your office or your house, that machine or that little connection, digitally speaking, is not going to know where to go from there, because there might be multiple machines. There could be 10, 20, or 100 machines in that environment. Which one does it need to go to? This is what's called port forwarding. Port forwarding, the router is going to go and forward that traffic to the right machine. So an example that I can basically give you guys here, I'm going to suck this one out of my thumb again, is imagine you go to a company. You know where the company is because you can go and look it up on Google. You can use a GPS, or maybe you've even been, maybe you've seen the building. So it's one thing to get to the building. It might be a very, very large company. Now imagine you finally got to that building and you stopped at the reception now. You are at reception. There's a receptionist, maybe more than one. And now you don't know where to go to in that building. It might have thousands of people, tens of thousands of people even. So now how the frick are you going to know where to go to in that building? You know you're supposed to be in that building. You might even know what department you need to go to, but you don't know how to get to that department. So what you can go and do here, I'm just spitballing here as an idea. You could theoretically go and ask that receptionist that, hey ma'am, hey sir, do you by any chance know where this department is? Let's call it department X. And he or she will tell you, you know what? It's on floor 4 and it's on the second hallway and it's in room 45. I'm sucking this out of my thumb as I'm going along, so I apologize. So that receptionist is effectively doing something called port forwarding. She or he is forwarding you in the right direction, basically giving you directions, for the lack of a better term. Now your router does the same thing. So when someone lands at your router or router, that's like landing at reception. So from there, that outside traffic does not know where to go. And that's what port forwarding does, is it forwards it to the right machine just like that receptionist that's going to forward it to the right place in that building. So I hope that makes sense. I've been known to just suck things out of my thumb as I go along. And I think I didn't do too bad there. So feel free to drop me a comment down below. Let me know what you thought of that example, because I kind of sucked it out of my thumb at the last minute there. But let me know. I've been known to talk nonsense. I mean, obviously it's about legit topics like this one. But let me know down below what you think of these weird examples. Alright guys, moving on. So here we have something called Windows Remote Access Tools. Now, there's actually, quite frankly, many tools you can go and use to go and access machines Windows-wise, remotely. But when it comes to Windows tools, some of the two most well-known ones are Remote Assistance and Remote Desktop. These are built into all Windows machines, not just Windows 10. You can even find them on the old versions of Windows. Remote Assistance is not actually something we use anymore. It's not that bad. It's just there's better tools out in the market. So remote assistance, like the name suggests, is to give you assistance remotely. So if you or someone requires assistance, technical wise, on your machine, you can go and open remote assistance. You literally just go type it into Cortana. That's the little search block at the bottom left. You type that in. It's going to open the little wizard for remote assistance. You'll see it's very easy. It actually explains itself once you go and type that in. And in that wizard, it's going to allow you to create what we call a little invite file. It's a very tiny little file. And the idea of that little file is you're supposed to send it to the person that needs to give you assistance. So if you are the person requiring assistance, you would go through the whole little wizard, make that little file, and send it to the person that's going to be assisting you. And they're going to go and open that file on their side, and it's going to establish a connection from their machine, wherever they might be, to your machine. So remote assistance allows them to see your desktop, your computer screen, and you can see the same thing at the same time. So whatever you see is what they see. You can move the mouse and the keyboard like you can expect because it's your machine, but at the same time, that other person that's remote now can also move your mouse and keyboard. So whatever you can do, they can do. You just happen to be sitting in front of the machine, and they happen to be remotely, but what they can do the exact same stuff as you effectively. Now, not even Microsoft actually uses remote assistance now. They actually use third-party tools like TeamView and all kinds of other ones, which is kind of funny. Remote desktop, however, is still very widely used till this day. There's so many reasons as to why you might want to use it and how you might use it. I mean, just a moment ago, you guys saw me use that in the cloud to access a virtual machine running in the cloud remotely. That was remote desktop, also known as RDP. So you do not need to go and install remote desktop. It's on all servers and desktops by default. You just need to go and tweak it a little bit. So the machine you're connecting from, you don't really need to configure anything. All you need is the destination's IP address or that destination server or computer's name. That's all you need. The one that you are connecting to, on that machine, you need to go and turn on remote desktop because it's actually turned off on most machines, and you need to go and allow it for the firewall. Unless this unless this machine happens to be running in the cloud. So if it's a machine like a Windows 10 machine running in a cloud, remote desktop is actually turned on by default and allowed by default. Unlike a virtual machine and a physical machine on premises, where it's turned off and blocked by default. Now, why is it turned off and blocked by default? It is for your own safety or for the average user safety. Now, unlike you that knows something about IT, the average Joe does not know anything about computers. So this was turned on by default and allowed by default. People like you that know something about something can very well easily take advantage of those other people, connect to the machines unauthorizedly, and do all kinds of shenanigans. That's just plain not good. So yeah. Now, with remote assistance, we said both people can see the exact same screen at the exact same time. Remote desktop, not the situation. So if that remote person remote desktops into your machine, it's going to kick you out to the logon screen. It's going to say you've logged on from somewhere else. If you happen to log back in, it's going to kick the remote person out and vice versa. You can keep kicking each other out like that if you need to. All right, so I think let's show you guys how and where you go and configure remote desktop. So let's go back to that Windows 10 machine. All right, here we are back on that Windows 10 machine. So first of all, if you want to go and find remote desktop, you can find it in many ways. You can just go and type it in if need be. There we go, remote desktop. And here in that block, you just type in the destination's IP address or the destination machine's name. Now, by default, this machine that you're connecting to has to be within the same building, same network. There is ways around that. I mean, you can go and use VPN, which digitally speaking teleports you to that destination. But in a nutshell, going according to all the defaults, you need to be within the same network. In other words, in the same building at the very least. So the PC that you are connecting to, on that one, you would remember, you need to go and configure a few things. First of which is turning this remote desktop function on. Secondly, allowing it. Now, where do you turn it on? We do that normally in system protection, but you can do this in many places. So I'm going to go here to my normal Explorer and just go to my system properties for this machine. Right click, properties. It's not the only place you can go and do this. Let's expand this. And then way on the right here, there we have remote desktop. You go click on that sucker. And you just need to go and turn it on. Now mine is turned on already. It actually was turned on by default because, like I said earlier, this machine is running in the cloud. And if this was not turned on by default, I would have no way of connecting to this machine in the cloud because I'm currently using remote desktop coincidentally as we speak. I mean, how ironic is that? And if this was on premises, this would probably be turned off by default and you would have to go and turn it on. I cannot turn this off because it's going to drop this connection to this virtual machine in the cloud. Now, something else you need to go and do besides turning that button on there is go and allow it for the firewall. Something we showed you guys accidentally earlier, but let's show it to you guys quickly again. So you're just going to go to your control panel. There we go. System and security. Firewall. Allow an app or a feature through the firewall. You scroll down to the letter R. That's why I actually gave you guys that example. So I'm just going to scroll down. There we go. Mine is allowed. So you're going to find that this thing is actually unticked by default. So you just go and tick those little boxes. There might be a third column here that says domain. If this machine is joined to a domain, just tick all the boxes and there you go. Presto. The remote desktop session is allowed to that machine now. So that's all there is to it, guys. Easy peasy. Okay, and then moving on to an entirely new topic, IP configuration issues. So this is all about IP addresses and them not working or there being some sort of shenanigans up. So what you guys see there in blue, the /all, /release, renew, display DNS, flash DNS, those are commands that you're going to be using in command prompt. So that's the black console that you get when you type in CMD. So in command prompt, we're going to be doing this in a moment with you guys. So in command prompt, you can go and type those commands. But in front of those commands, you normally need to go and type in ipconfig. So it's going to be ipconfig /all, ipconfig /release, renew, and so on and so forth. So what does these commands actually do? Normal ipconfig on its own shows you basic IP information about your machine. So, and if you go and type in ipconfig /all, it shows you the same information but in more detail. ipconfig release releases your current IP address, but it only is applicable if you're using a dynamic IP address. So if you have a dynamic IP address, which means you get it from a DHCP, remember that IP expires and you get a new one pretty much every day or so. So you can manually go and release it by typing in that command, which is the same as turning your machine off or unplugging it from a cable or disconnecting it from a Wi-Fi. It releases that IP address back into the pool. And then right after you've done that, you can go and type in ipconfig /renew, which requests a new IP address, which is the same as plugging yourself back into the network or reconnecting to the Wi-Fi, or quite frankly, just turning your PC on. It's going to do a request. It's going to say, hey, I need an IP address, and you're going to get one. Now, surprisingly, that actually takes longer than restarting the PC in most cases. So I would say, you know what? Just restart your PC. It's quite frankly going to be quicker. The only times you're going to go and use those commands is if you, for some weird reason, cannot restart that machine. Maybe you've got something open that you cannot save at that point in time. That would probably be a good example. Now, the second last one we've got there is display DNS. It's not going to actually do anything, that command. It's just going to display to you what your DNS server's IP address is. So then at least you know, okay, I have a DNS or I don't. And if you do, what is its IP address? Flush DNS flushes all your DNS records. Now what happens is you actually need to understand DNS to really understand the complexity of what this command actually does. But when your PC goes to a website, it contacts the DNS server and basically asks the DNS server, where is that website? So maybe you typed in www.youtube.com. Your computer doesn't actually know where that is. So what it's going to do is it's going to contact the DNS server, which keeps records of all websites and what their IP addresses is. So it's going to ask the DNS server, hey dude, I just had YouTube typed into me by my user. I have no clue where this is. Do you know where this is? DNS is going to be like, okay, dude, I've got you. Let me go and check. YouTube. YouTube. YouTube is 192.168. It's basically going to give your PC an IP address. And your PC is going to be like, okay, sharp, cool. Thanks, dude. And it's going to go and use that IP address to find YouTube on the internet. That's what happens. Now, as your PC accesses websites on the internet, it caches them on your PC's temporary memory in its cache. So it's the same as you going to a location, physically speaking in real life. If you're going to a certain business or a certain building the first time in your life, you're probably not going to know how to get there. You might Google it, and you're going to go and use a GPS to find your way there. But once you've been there once, you know how to get there, generally speaking, because of your short-term memory. You're going to remember. So the second day or the third day, if you have to go back there, you might very well not need a GPS again because you remember how to get there. That is the same as your cache on your PC. If it's been on a website recently like YouTube, it's going to remember how to get there. So now when you haven't been to a place in a while, let's say it's been a year or two, you might have been there before, but it's been so long that you've forgotten how to get there. In other words, your temporary memory no longer remembers how to get to that building or that address, which means you're going to have to go and resort to using your GPS again. So the same applies to your computer. Your computer will remember a website, but if you haven't been there in ages, months or years, eventually it forgets how to get to that website, and it's going to have to re-ask the DNS that, hey dude, I forgot how to get to YouTube. Can you help me? What's the address? So that flush DNS command, now finally I can get to that. Flush DNS is simply going to go and erase that temporary memory. So if you want to go, we don't normally go and do that. The only times we go and do that is if we suspect that those records are incorrect. So if you understand how DNS works, you can go and tamper those records and misdirect people on purposely in the wrong direction. And if and when that happens, we can go and clear those records so that your PC forgets those records. That's if you purposely wanted to forget, so it can start fresh and just get the new records, the correct records for that part. Another command you guys can go and play with in command prompt is the ping command. So you simply go into your command prompt, you type in ping followed by space, and you type in the remote destination's IP address or the remote device's IP address or the remote destination or device's name. Either or will suffice. So what it's going to do is it's going to send 4 packets of data, as you guys can see there on my picture. It's going to send 4 packets of data. They're extremely small in size, a mere 32 bytes, as you can see, to be more precise. Very, very small. And if the destination is there, and if it receives those 4 packets of data, it will send all 4 packets of data back. If you receive all 4 back, it's going to look like what you guys see in my picture. It's going to say reply, 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 reply. That's what you want to see, is 4 replies. Now, if you get no reply, in other words, destination unreachable or no reply, messages displaying your screen, that can be for a lot of reasons. But what it does mean is you've got no connectivity. It could be for something as simple as the cable is unplugged or the Wi-Fi is disconnected, the destination is not turned on. It can be for any amount of reasons. The point here is you do not have connectivity. But if you've got a reply, especially if it's all 4 of them that's replying, you've got connectivity and everything is hunky-dory. But if you do get a reply, but not all 4 of them are reply, that means you've got connectivity, but you've got some issues. You've got what we call packet loss. It could also be for any amount of reasons. It could be that maybe you've got a faulty cable, maybe you've got a weak signal if this is wireless. So it at least tells you that your configuration is correct, but you need to go and investigate as to why your connection is so terrible. Do you have a bad cable? Maybe it's a network cable that's near a power cable, which is causing EMI. Or maybe you've got a wireless connection, but they went and reduced the radio power levels like we spoke of earlier, and you're not near enough to it to receive proper signal. That could also be a reason for this. Now, something else we get in command prompt, another fun tool, is traceit, which we can be used for routing issues. So if you are having trouble, with connecting to a certain website, or your internet's a bit slow, or it's on and off, it's intermittent, you can go and use this tool to potentially being the keyword here, identify if you've got an issue on your network or if it's externally. So what tracer does is you type in tracer followed by the destination's website address or the destination's IP address. It's probably going to be a website of some kind. And it's going to go and trace that destination, as you guys can see in the picture here. Each of those numbers, 1, 2, 3, 4, is a hop. And in most cases, each of these hops is a router. It's not set in stone. It could potentially be other devices like a firewall. So the first hop there is usually going to be your router in your building, your household, or your office. The second hop there is probably going to be another router, which is probably going to be at your ISP's router. It's going to be at your ISP. The third hop is most likely going to be something beyond your ISP. So if you find those little asterisk signs that we see there, in this case we see most of them being there at the second hop, that means you've got a problem, but it's not your problem per se. It's going to affect you because you've got connectivity issues to that destination, but it's not your problem in the sense of there's nothing you can do about it. All you can do about it is log a ticket with the ISP in this case, because that is the ISP's problem, not your problem, even though you are a technician. If it was beyond the second hop or the third hop, then it's not even the ISP's problem. The only thing you can go and do is basically just wait and wait for it to be resolved. Then in a real life company environment, this is probably not part of the course, the first hop is going to be your router, or I'm lying, it's going to be your firewall, because real companies have a firewall, a physical firewall. So the first hop is going to be your firewall, since everything has to go through the firewall. The second hop is going to be your internal router, which means it's still your problem in this case. The third hop is going to be something at your ISP, could be their router or their firewall. And the fourth hop could be their router, or it could just be beyond your ISP. So all of these are situations you can go and consider. So in a nutshell, this thing allows you to go and trace something for a maximum of 30 hops, 30 devices in other words that it's going to go through. And you can go and trace in the end of the day what something's IP address even is. So if I want to go and trace Google, I can go and type in tracer space www.google.com or youtube.com, and it's going to show me a certain amount of hops, and the last hop is going to be Google's or YouTube's public IP address. And you can go and type that IP address into a browser, and it's actually going to take you to the exact same website, believe it or not. Alright guys, so speaking of believe it or not, that was actually the very last topic for Core 1. So as we stated earlier, Core 1 consists of 9 modules. So the first 9 of 18 modules is Core 1. And then from Module 10 all the way to 18 is Core 2. So we just finished Core 1, believe it or not. So with that said, please give this video a nice thumbs up. I've put in a lot of effort into making this video and this series for you guys. So that's basically my free payment. And like usual, if you are new to this series or new to my channel, subscribe. Otherwise, you're not going to know when I release videos. Preferably with that little doohickey they call the notification bell. I mean, that's just going to make you be informed so much more. You know, otherwise you might not know about a course unless it actually happens to pop up on YouTube. YouTube works like that. If you guys need any additional support for this module or for this course, you are welcome to drop me a comment down below and I'll gladly assist you. Alternatively, you can go look in the video description, and there you will find not just the timestamps for this video, which is going to make your life easier. You will find a Discord link there. That is a Discord server which does not belong to me, but it is a community. It consists of over 2,000 people at the time of this making. And in those people, or some of them are experts like myself, some of them are new in IT, they're just studying maybe like you. So either way, you can either get the support from me or you're going to get support from someone else. It's got different channels in there, you know. So you've got channels for CompTIA, you've got channels for Microsoft, for different exams and different courses. So you're bound to find some sort of help there, either for myself or someone. If you're looking for me on that server, you can find me under the name of Burning Ice Tech, same as the name of this channel. So guys, yeah, give it a like, give it a subscribe. I will see you in Core 2 of this series, being Module 10.
If you love me, let me know. If you don't, then let me.